Okay, now we are going for second experiment. There's a part 2 of the experiment, which is the empirical formula of magnesium oxide. Okay, now we're determining the empirical formula for the magnesium oxide. So the purpose of the experiment is actually to determine the empirical formula of magnesium oxide, and this is actually the procedure that we use for the metal which is more reactive than hydrogen. For example, let's say if you want to determine the empirical formula of aluminum oxide, then we use the same method. Instead of using magnesium, we will replace it with aluminum. Practically all these are being used for the experiment, okay, with any metal which is a more reactive than hydrogen. Okay, but magnesium oxide is taken as an example. Now, what are the precautions and steps that we need to consider, okay, to improvise your experiment? Okay, the one of them is actually the magnesium is a very reactive metal. Okay, it's a very reactive metal. That means we cannot find this metal in the oxide form. So it is already been reacted with the air to form a layer of magnesium oxide. Okay, therefore the picture will be looking like this. This is the original magnesium oxide. This is how the magnesium oxide look like, and this is how the magnesium, pure magnesium, look like. So what we need to do, since our magnesium oxide is already been oxidized, so what we use is we use the magnesium ribbon is polished with the sandpaper to remove the oxide layer on the surface before you can actually carry out the experiment. Then, so you can polish it. Okay, you can get the metal like that, or you also can polish in this manner, so that once you polish the things, you actually remove the oxide layer on top of the magnesium. Now once you got a magnesium, pure magnesium, now we got the next steps. The chemical reactions that involve in this thing is actually the magnesium react with oxygen to form magnesium oxide. See, the formula is MgO, but you see, if you want to balance it, magnesium is Mg, 1 and 1. Oxygen is required is 1, so I put the half times with oxygen, O2, it will give you 1, so 1 and 1, so it's balanced now. But in exam, we cannot write half here, so what I do, I times everything by 2, so I times here 2, so you get 2 Mg, O2 give you 2 MgO. This is how we write a chemical equation in exam. Now, if normally the SPM papers or any examination papers which is related to your empirical formula of magnesium oxide, they will ask you to write the chemical equation, so this will be the chemical equation. Now, while you are carrying out this experiment, when the magnesium is burns in the heated up or burns with oxygen, the magnesium oxide form in the gas form, and this gas form is a white smoke. And when it's cool, the magnesium oxide will become a solid, and that will be the white powder. So how you can prevent the white smoke from escaping? So you have to make sure that the lid of the crucible need to be always closed. If let's say if you opened it, can you see the smokes here? And this is the smokes which has been coming out from the crucible when you open it. And the more you go smoke is escape, the mass that you are obtaining for magnesium oxide will be affected. That means the experiment becoming no longer accurate. So prevent as much as you can from oxygen, the magnesium oxide from escape, or the white smoke from escape. Okay, therefore when you open the lid, make sure you close immediately after you have lifted. Okay, the next, oxygen inside the crucible might not be sufficient for the complete combustion of the magnesium, because you are closing the lid, therefore it's not enough. So what are you going to do to overcome this problem? So all you need to do is, during your carrying out the experiment, okay, during the heating, the lid of the crucible is lifted at a certain interval, to allow the oxygen from the air to enter into the crucible. So use a tongue, hold the lid and open it slowly here, let the oxygen or air to go in to give a complete combustion. Okay, next. How do you know? Okay, how do you know the reaction is completely reacted? Okay, this only can be achieved by the heating, cooling and weighing process is repeated until a constant mass is obtained. So you have to do this step until few times until the mass of the final reading is the same. Now, what is the crucible is made of? It is made of silicon oxide. Now, do you think that crucible may react with magnesium at a high temperature? Yes. So now this will affect the reaction, affect the experiment. So how you can avoid the reaction between the crucible and the magnesium? So to do that, that's the reason why the crucible is laid with a piece of what? Asbestos paper before the magnesium is heated. That's one of the reasons why we are putting the asbestos paper below the crucible. Okay. Now the next, we are going on to the analysis of data. Okay, to achieve the aim of the experiment, the empirical formula. So what you require in an analysis of data is, let's say the mass of magnesium is X and the mass of oxygen is Y, then the number of mole atom is X over 24 and Y over 16. Definitely we cannot write what is the answer here 1 and 1 because value of X and Y is unknown in alternative to practical. Therefore I filled up it as R and S. If R and S, the empirical formula will be MgROS. That's empirical formula. So you can write like that, or you can write as MgO. Now, what is the problem I'm facing in this? I need to know what is the value of X. I need to know what is the value of Y. Now, to obtain this value in X and Y, for me to carry out the analysis data, therefore, I'm going into the tabulation. What is the requirement inside the tabulation data? That means I must calculate the mass of crucible, lead, and asbestos, measure it, and we'll get the answer is 8 gram, let's say. Magnesium plus with the mass of crucible, lead, and asbestos, that's give you 3 gram. After the reaction with the oxygen completely, that's give you the value of 3 gram. Now once you can get that, that means C minus B will give you the mass of oxygen. B minus A will give you the mass of magnesium. So the X value is B minus A. The Y value is C minus B. So this is how we obtain the value of magnesium and oxygen that reacted with magnesium. Now in this question, what are the variables here? The manipulated variable is the mass of magnesium ribbon that you use, and what is the corresponding? The amount of magnesium oxide formed. The type of metal used and the mass that we use is become the constant variable of this experiment. Okay, what is the hypothesis? The higher the mass of magnesium ribbon is used, the higher the mass of magnesium oxide formed. Okay, and what is the inference? This is the inference of the experiment. Say the magnesium ribbon used in the experiment influenced the mass of magnesium oxide. Now this is a hypothesis, inferences, and the variable of the experiment. Now we are going into the procedure. Okay, the procedure of this experiment, and we have carried out an experiment here. There's 2 videos here. It's been given for you to watch related to the experiments. Okay, and this will be the how we draw the arrangement of apparatus for the exam. Okay, we draw this one. We don't use this diagram. This is a 3D diagrams, so we don't need to draw as sophisticated as this. As long as you can draw something like this for the exam is sufficient enough. Where we have a crucible, we have a asbestos, we have a magnesium and coil, and we got a lead, and we got a pipe clay here. Okay, then we heat it up. So this is a standard diagram for this experiment. Okay, and next steps, what we need to do, we need to get an empty clean crucible lined with the asbestos, with the lead is weighted, and the weight is recorded as a A here. Even though there is a reading here as 34.57, so I will write it as A, because while we are carrying out this experiment in the laboratory and alternative to practical, we don't have these values. So we write there as an A only. Then the next step, we need to take a 25 centimeter of polished, okay, centimeter of ribbon, magnesium ribbon of length 25 centimeter is polished with a piece of sandpaper. So you polish it. So after you polish it, what happens? The clean ribbon paper is rolled into a loose coil and put inside the crucible, which is contain a piece of dry asbestos placed in the crucible. So put you inside the crucible. So once you do that, okay, you close the crucible Okay, you close the crucible and you weight it again. Okay, the crucible with the content are weighted again and the reading is recorded. So as the reading here is 34.79, but we are recording as a B. Okay, record as a B. Then we will heat it up. The next step is heat it up the crucible for about 15 minutes, and the lid is lifted from time to time to allow the oxygen from the air to enter the combustions of magnesium. So this is how we open it slowly. Okay, just open a bit like what is shown in the diagram. Okay, then what you do not care need to be taken to prevent the white smoke of magnesium oxide from escaping by closing the lid immediately after it is lifted, and this become an precautions. Okay, now then when the magnesium does not glow anymore, stop heating and the crucible is allowed to cool and weighted again together with the lid, and this weight is recorded. This is still hot, that means the experiment is not completed. In this case, is once it's cool, he become a white powder. So then it is you can actually measure the weight. Okay, the next, so what you need to do after that, the heating, cooling and weighing process is repeated until a constant mass is being obtained. So in this case, the third reading is obtained as a C, even though it's recorded here is 34.94 gram. Okay, now we have actually completed the experiment. Okay, then we have a list of apparatus that we needed in this experiment is safety goggles, magnesium ribbon, magnesium balance. Okay, then a ring stand, Bunsen burner, ring stop, or clay triangle, crucible lid, tongs, and clay tiles. Okay, the clay tiles is put it on the below of the Bunsen burner. Okay, then we can conclude that the magnesium empirical formula of magnesium oxide is Mg. So this is how we carry out an experiment for magnesium oxide experiment. Now we have actually completed the sections of empirical formula and molecule formula for our syllabus. Thank you.